We are Patrick and Jakub, and this is the Mining Your Business podcast, a show all about process mining, data science, and advanced business analytics. Jakub, how are you doing today?
I'm doing quite well, Patrick. Thank you.
Boudewijn Van Dongen, a professor at the University of Eindhoven and chair of the IEEE task force, joins us on the podcast today to finally explain to us what is conformance checking, what it isn't, and the various ways it can be used to discover hidden errors in your process. Let's get into it.
I will start this episode off with a foreword by Wil van der Aalst, one of our previous guests on the show, to the book Conformance Checking, Relating Processes and Models by authors Josep Carbonara, Boudewijn Van Dongen, Andreas Solte, Matthias Weidlich. Here we go. Conformance checking is an important but also challenging topic in process mining. Most people who see process mining for the first time are dazzled by the process discovery capabilities of today's process mining tools. However, when people really start to use process mining, more detailed questions emerge, and it is no longer sufficient to look at fancy process diagrams composed of boxes and arrows. Conformance checking will be a focal point of today's discussion. However, not the only one. With our today's guest, Professor Boudewijn Van Dongen from University of Eindhoven. Boudewijn, welcome to our show.
Thank you.
It's really a pleasure to have you here. And I guess my first question really would be, you are currently a full professor at University of Eindhoven, and my question would be, what does it actually look like, and what is your area of expertise?
Right, thank you, Jakub, for inviting me, and Patrick for hosting me today. So I'm very happy to be here. So indeed, I'm at Eindhoven University, and I'm the exceptional, I'm the odd one out here. So I came to this university in 1998 as a student, and I never left. So from an academic perspective, that is sort of the worst career path you can have. But I'm really enjoying myself in Eindhoven. So my group is a small research group focusing on all aspects of process analytics, both in the foundational theoretical results that we are developing, for example, in the area of conformance checking, but also on specific application areas where we have industry in the Eindhoven area interested in actually co-developing and co-creating the technology of the future in process mining.
Mm-hmm. So can I ask, what subjects do you actually teach at Eindhoven?
Yeah, so we have a couple of courses. One of the courses that we're responsible for as in our research group is a foundational course on data analytics that starts in the first year bachelor of all our university's programs. So over 2,000 students a year participate in that. That's the first time our students get a glimpse on what data science is actually about. And the key point is that we try to teach our students that they are that data science is not just about changing or improving the error by a small margin, but it's actually about solving a real problem for a company. And we have various courses that have this kind of background, and all the way into the master, where we teach advanced process mining topics, such as real-time process mining, so doing process mining, but then in an online setting, or courses specifically on discovery, specifically on conformance checking, on healthcare applications, which is a very dedicated topic. So these are the sort of topics that come back into our course program throughout bachelor and master.
So we are a show dedicated to process mining, but neither myself or Patrick really studied process mining. We had different career paths, and somehow it just split us here, or spitted us out here at process mining. Can students actually apply in Eindhoven for a career path or of let's say, a process mining architect, or is it just some kind of a little deviation from the normal curriculum?
No, so process mining is an important trajectory within our masters. So we have a dedicated master on data science and artificial intelligence, and within that master, process mining is it's part of the core curriculum for all the students. And there is really a specialized track preparing students to becoming maybe not necessarily a process mining architect in the sense of software, but maybe becoming a process mining expert in translating questions from companies, from businesses into a question that you can answer with process mining technology.
Mm-hmm. So how long have you been exposed to, or when did you first learn about process mining?
That's a funny story. So this happened in 2000 and 2001. I was a third-year student, and I was not the most active student. And that meant that at the time I was supposed to do an internship. And to do an internship, you normally would have to reach out to a company and sign contracts and spend a couple of months inside. But I just woke up one day and realized I did not take care of doing an internship, and I had to start one next week. So my girlfriend at the time, she had been in contact with Wil van der Aalst for a very long time about doing a project with him. And she told me, Wil is looking for a student to implement the alpha algorithm. He must have told you about that in the podcast. And then I went to him and said, look, I can do programming. So if you want me to program an algorithm, I can do that for you. So he gave me this assignment. And Wil has no idea about programming. So he expected this to last for a couple of months. But then I came back after a few weeks and said, look, I implemented this algorithm, so now what? And that was actually the point where I learned that implementation requires testing, because there was still quite a few bugs in the actual implementation. But at the same time, Wil challenged me to come up with new ideas, new extensions to the alpha algorithm. And that's when I first started sort of getting acquainted with doing research. I had no idea what it was at the time. And slowly in the course of these couple of months, I stuck with that research group. So I kept on doing some implementation work. And finally, at some point, Wil suggested, can you come and do a PhD with me? And that's how I entered into the subject.
That sounds amazing. We did have Wil. I think the only thing he was mentioning was, ideas coming up while having a beer. Not sure whether this was the exact case.
At some point, sure. Yeah.
At some point. So, one of my other questions would be, since we have a lot of, I would say, also students who are at their at this point of their careers when they are also considering, do I go to work in business, or do I actually pursue this academic career? Since you mentioned that you were inspired by Wil and started to work on an algorithm with him, can our listeners or generally students also reach out to you or some acquaintances of yours to pursue some academic research in process mining field? And where would you point them to, if yes?
I think every researcher in every university would be happy to talk to students who are interested in doing some sort of research-oriented task, research assignment. So we have various opportunities for that in our university, but also I'm sure all my colleagues share this. We're always looking for. So how should I phrase this? I understand it's a very difficult choice to make when you're 22, 23 years old, and you need to decide whether you stay at this university at a typically lower salary, spending 4 years writing a book, or do you go to industry, especially in process mining, where you get a car and a house and a salary that is 3 times that of your colleagues? That is a very tough decision to make. Mm-hmm. I really understand that. I think it's worth staying at the university when you're young, because the moment you step away, it will be far more difficult to ever go back, and you might regret that decision.
Mm-hmm. So can they reach out also at some point, maybe even to you and your team, if they are interested in some of the topics that we are going to discuss today?
Of course, yes.
Sounds great. Then you heard it. If you are interested in pursuing career in process mining in academia, you are always welcome. And there can be never enough of researchers on these topics. And maybe one comment from my side: unfortunately, we don't get cars or houses, even though we do work in business.
That's unfortunate.
Maybe we picked the wrong company.
Yeah, maybe Jakob, we should think about this.
The main topic for today should be a conformance checking. And Boudewijn, I know you wrote a book on this. Maybe could you give us a little introduction into what the book is really about, and later on we'll get into the conformance checking itself, because this is a topic that we haven't properly discussed on the show yet, and it feels, from what I've been studying and as a part of preparation for this episode, that this is really something that we should devote our energy more towards too.
Yeah, the topic of conformance checking is something that so when we started doing process mining, the idea was always that if you take an event log and you look at it with the right algorithm, you get a perfect picture of the process. But in practice, we soon realized that there is actually a difference between a model and the process itself. Every single model that is ever being made of a process, and that can be a formal model in terms of, a PetriNet or a direct succession graph or even a handbook. Every single model is always an abstraction of the reality of the process that's actually taking place. And in any practical situation, you have exceptions, you have cases where you have to work around the system, where you have to make sure that something just works because it has to work. You have an important customer, and for that customer, you're willing to bend the rules a bit, right? So that is part of the process. It's not part of the model. And in the early process mining research, the model was always seen as a synonym for the process. And very soon already was Anne Rosinat, who in her PhD looked at this relation, looked at a process model and an event log, and said, let me try to capture and quantify how well these two fit together, right? And she came up with metrics to analogy to the analogous to the data mining community, where you talk about recall and precision. She talked about fitness and precision. How much behavior that I've observed is actually explained by the model, and how much more behavior does this model have with respect to the observed behavior. Later, it was Arya Adriancia, a PhD student of Will and myself, who developed this further and made a sort of computationally sound technique that works in the general case. Said, well, if you have a process model and an event log, I can tell you where and when there are deviations, and we can explain exactly where this model does not agree with the data that was observed, and how we can fix that, either by labeling something in the log as this probably didn't happen, or it should not have happened, or by adding something to the log and say, well, here there is a step that probably happened, but it wasn't recorded. Right? So the very, very simple concepts, and he did the groundwork on that. And that eventually led to the book that we wrote. I did not write this alone, not by a long shot. So I think Josep, Matthias, and Andreas deserve all the credits for doing that together. But there we tried to take this one step further. So we said, now let's look at process modeling in relation to this notion of a process, right? Abstract, conceptual thing that everybody knows exists, but nobody knows how to exactly explain it, versus a model that is, in our book, a PetriNet, but can also be a BPMN model, and an event log. And that event log is the thing that, of course, we study in process mining extensively, but also there, we're the idea in research of what a event log is also shifting a bit.
So basically, when it goes about the conformance checking, and I also will quote your book now, that conformance checking quantifies the relationship between data and a model in order to say something about the process. What can conformance checking actually say about the process?
Well, maybe it's good to explain to you this a bit in terms of an example. So we I don't know if you've heard, and if your listeners have heard of the BPI challenge. So this is a challenge that in already for quite some time we publish a data set coming from a company, a real life data set, and we ask the research, but also the professional community to show what you can do with your techniques on that data set. Can you answer the questions of this business owner? And back in 2012, we published a data set that came from a small financial institute in the Netherlands, where consumers can ask for a small consumer credit. And a small consumer credit for a bank means an amount of a loan between 5,000 and 50,000 euros.
Mm-hmm.
And this is a data set that actually has a very structured process behind it. It's call agents, so people, mainly students, that call customers after they fill in a website to ask for, or to make offers, to ask for details, to come to an agreement on the terms of every loan. If we look at that event log, we can actually extract a model by hand. So there's not a single process mining tool that can do this fully automatically, although one of our PhD students is getting close. But we have a model that is actually describing quite accurately what that process should look like.
Uh-huh.
And we validated that model also with the business owner. Look, is this indeed how you work? And he said, yeah, that's pretty much, that describes how we think the process should go. And now you can relate back the event data to that process model. And then we see two categories of deviations. And one category is around the making of offers. There is an activity in that log that says offer sent back. And so that means the customer has sent back an offer because either the customer accepts the offer or the customer says, I don't want it, I want another one.
Mm-hmm.
And interestingly enough, that step is very often missing from the data. So then the process continues, new offer is being created, but the old one was never sent back. And sometimes it's even like the loan is accepted without this offer being sent back. That's very confusing. Now, and this happens a lot, right? It's really a lot of times. So we talked about that with the business owner and then also some of the call agents, and they soon realized that this was actually a nice example where the call agents figured out that they should work around the system, because the system was implemented in such a way that you could only have one offer live per application. And what your customers want is they want you to make two offers that they can compare. So what they did in practice, they printed an offer, they canceled it without it being sent back. They created a new one and printed that too, then sent two offers in one envelope to the customer. And if one of them came back and it was coincidentally the first one that was already canceled, they would have to go through this process again. Right?
Oh, wow.
Cancel the outstanding offer, recreate the original one, and send that through. So that's a clear example where by looking at the difference between data and model, you find out that the process is actually executed correctly, but that the system is not supporting it properly.
So the model that you build with the business people is then what is a should be model of the reality, and then you compare it to what is actually happening in the event log, and that is what is known as conformance checking.
You could call it as an as should be model. When you ask somebody to draw a model of a process, you typically will be presented with it as if it's an as is model. So they will say, this is how we do things. But indeed, you're right, it's more of an as should be model. And the differences that you identify clearly show, well, this is how it should be, but this is how things are going on.
So is it always about finding the gaps, or is it also about identifying activities that are happening too many times, or what type of conformance can you actually measure here?
No, of course. So typical examples would also be ping pong behavior, right? Something that you may recall from especially incident or ticketing systems, right? You immediately reply back to the customer saying, "Oh, please give me more information," and there a model would have like any model of that organization would show a loop, and by looking at how often do you actually go through that loop, and that is also conformance checking, right? You also replay the data on this model in order to identify how often do you go through a specific part of the process, you would be able to identify this type of behavior. Similarly, you could identify parts of the model that are never used. Right? Also, that happens. We sometimes have very complicated processes defined that are not necessary. And so one of the BPI challenges, I'm not afraid to say that, was the data from our own university. And there was an approval step of travel declarations in there that was essentially never rejected. So the question is why the approval step is there anyway.
What if?
Well, indeed. Yeah, in this case, it was a what-if scenario because the person having to do this approval step is technically responsible. So, yeah.
So what it seems to me like from just listening to you, and we've had a lot of guests both from process mining world, and as we started the podcast, we realized process mining is more, or just the business process management is more than process mining. So we also had a lot of people who are on this modeling part of the end of the spectrum. Does this mean that let's say conformance checking kind of closes the gap between process mining itself and this sole business process modeling?
Yes, to some extent, yes, because business process modeling comes is traditionally done by people who are experts in the process or in similar processes. If you talk about consultants, but they do this by talking to experts and stakeholders. They draw a picture of the process. But talking to stakeholders, you will not see the dirty sides of a process, if you will. And and this is not a bad thing, right? The models should exist, and they should be made in a comprehensible way by people who understand that what the right level of abstraction is that you want to talk about the process. But you cannot assume that when a business process management expert has drawn a picture of your organization, that picture accurately represents the truth. It's an abstraction, and the deviations matter.
So maybe a next question would be, if I am an organization and let's say I have all the tools in place, both process mining, both business and business process modeling tools, how do I engage in conformance checking activities? What should I do and how should I address that?
Well, I think the first thing you should do is to reach out to your process mining vendor and tell them how important this topic is to be included in their tooling. So at the moment, not too many commercial vendors have a ready-made solution. There are some, and it's gaining also momentum on their side. But I think in general, the attitude towards the results you get out of your process mining tools is to be always a bit wary of the picture you're presented with, and especially what are the things that do not fit in this picture. So everything that you see when you look at a picture made by Celonis or UiPath or any other commercial product or non-commercial product, every arc, every node is probably explainable in terms of the data that underlies it. What you don't see is what part of the data is not explained. And that's where conformance checking comes in. So make sure that you always ask your vendor, what am I not looking at?
So how do you envision a proper tooling to look like, right? Because we have seen this in practice, Jakob and I've seen this in practice, and essentially it boils down to a list of activities and in sequence asking you, is this okay? Yes, no. Is this fine? Yes, no. And then you just kind of set it as, yes, this is fine, this is not fine. And then it kind of gives you a list of what's conforming and what's not conforming. In your opinion, what should this actually look like? Is it fine the way it is, or?
Well, so it's an interesting question because this is very much a research challenge. So there is not a off-the-shelf solution that provides you with a sort of a complete insight into the deviations into conformance checking results. The very rudimentary question, is this deviation okay or not? Right, that's a very first approach. Like intuitively, the visualization capabilities that our tooling and also commercial tooling has are quite powerful. So you can actually present the picture of the process that you discovered, and in the same image, maybe with a different color, maybe with a different shading. I'm not a visualization expert there, but you can present also the parts of the data that were left out of this picture, and maybe you can even add the things, especially if we're talking about man-made models. So models that are put in there not by a process discovery tool, but by a person saying, this is how we work. This is even more important. But I think a projection on the level of the model is definitely important.
So when you look at this in research, I'm not sure about the size of the data that you're looking at, but when we look at it on an enterprise level, we often see processes that are massive, data models that are massive, and we're talking about millions up to billions of activities and things like that. How does conformance checking scale in terms of this billions of activities?
Yes, that's a nasty question to ask an academic. But there's two sides to the answer. So on the one hand, I think if you look at the also what we presented in the book and the work of Adriancia, essentially that is a solid mathematical foundation for conformance checking that doesn't scale properly. Right? That it's a very complicated, like theoretically very complex problem. And doing this on real life examples, if you make the right examples, you can break the software. Right? It simply will never finish. At the same time, there are not many real life scenarios where the deviations are precisely of that form. So you can actually make fast and efficient tooling that is able to find deviations in practical scenarios relatively quick. So that I think there is a role there for both academia, right, trying to also properly define heuristics that work in specific cases, as well as for the commercial vendors to implement heuristics, to implement fast versions that might not always give perfect answers in every scenario, but in 9 times out of 10 or 99 times out of 100, they're spot on.
Please go ahead, Patrick.
So if we just also talk about the size of the event log, what about just the different types of activities? If you have just 1,000 activities, but they're all different, how does conformance look in those cases?
Yeah, so the technology, the scaling of the technology is quite bad in the size of the models. Not so much the log necessarily, but experimentation that we've done shows that you're the worst off if you have a fitness of around 80%. So that means that 20% of the data is actually not properly represented in the model. And if that 20% is randomly distributed over your events, then it's tough to identify precisely where this happens. In practice, if you have a process model that is so far off, you probably should trim it down to smaller chunks and say let's not look at one monolithic model of our process, but let's look at smaller parts and see if we can already identify deviations in specific subparts of the process before going to the whole thing. But again, the challenges there I think are twofold. On the one hand, there's a computational challenge that mainly I think is the responsibility of vendors to think about scalable sort of heuristics. And at the same time, there is also academic challenges, how to deal with this complexity from a fundamental point of view.
Speaking of complexity from the fundamental view, at some point, these analyses are performed by either business users or data analysts such as ourselves. How do we conduct a proper conformance checking analysis? What would be the key drivers and what to focus on when doing that? Should we, let's say, maybe first question would be, should we start with requesting some model as should be from the business and then comparing it to that, or should we just derive, let's say, a happy path and then just keep going down from there?
I think both are possible, but the just taking sort of a discovered happy path, that's probably not really the way to go. But what you would be able to do is to use discovery techniques to build a understanding of, to build a model yourself. So you use the input of the discovery technology to get a model, a process model, as it would also be made by maybe a consultant. So you get an as should be model with input from the discovery algorithms that you validate that with your business owner. So the process mining tool says this. If I translate that into a model and I combine a couple of variants that I found in the data, then I get this process model. Is this indeed properly describing your main process? And then you can use that to relate it to your data and say, well, and now we find deviations. And sometimes these deviations give rise to updating the model. Sometimes they give rise to updating your information systems because your model is correct, but apparently your data is correctly showing what should be done, but the system simply doesn't support this. And sometimes it also gives rise to really questions in the organization. They look, I'm sorry, but what happened here? Right? To refer back to the BPI 12 example with the financial institute, we also found 3 cases where there was no signature recorded, but loans were paid out. So that means the customer was paid out a loan that he or she did not accept. Now, I'm quite confident that this missing signature explains the hundreds of call the customer events that we saw after paying out the loan. I would also not answer the phone anymore. Would you?
No, not likely. So in terms of conformance checking, how does it compare to other process discovery methods? And in what cases do these other process discovery methods fall short where conformance checking can pick up the pieces?
Well, all right. So it's not a process discovery method, right? Where I think it's a nice addition to the sort of the broad scope or the broad field of process discovery is that you, with discovery, you get a particular view on a process, and very often represented as direct succession graphs and multiple direct succession graphs when you look at different variants. What you can do with conformance checking is exactly what I described before. You take these different views together, you make your own model of what is the as is or as should be process, and then you use that and compare it with the data that is there to identify where there are still deviations. So it's not. I wouldn't say it is a. It's not a complementary technique. Sorry, it's not it's not something you can do instead of discovery. It's complementary to this discovery algorithms, and it basically allows you to take your discovery results and focus on where there are still improvements to be made in the organization.
So I remember when I was starting in process mining business, one of the first things was that I asked my colleague, "What is this conformance checking tab and what does it do?" And he told me, "Yeah, don't go down that road. Just don't use this report because it's just challenging to explain everyone." And basically, I have never used it ever since, which I'm now very sorry to even admit, but it's the truth. The question for you would be, why do you think that this practice specifically is so reduced, or let's say omitted, very often during professional implementations? And why don't really customers and people who are conducting process mining activities looking into conformance a bit stronger? What is preventing us from that?
So I think the reasons why this was the case, and I think it's slowly changing, but the reason why this was the case is that with simple process discovery, you could already identify quite a few improvement points in your processes. By looking at this direct succession graph with some timings on the arcs, you could say, look, here in the process, we have a lead time of 4 days between these two activities, and that in our mind should be 1 day. So you already have very clear points for where you can start improving your process. At some point, that well dries up. So you will not be able to only look at discovery graphs. You will need to start looking at things that are not in the graph, or the things that are happening and that are filtered out somehow, in order to really reach true improvement steps.
Mm-hmm.
So it will be there in commercial tooling more and more. It just wasn't ready yet. And yes, it's more complicated to explain than just a direct succession graph.
Yeah, maybe if you did a conformance checking on our implementations, you would find out that we usually take the easiest road. Unfortunately, because everything we do are processes. That's what we learn.
Shh, don't tell him that.
Anyhow, what are some of the key, let's say, applications where you could think of process conformance checking as a go-to method in your processes? Like, where does it make most sense? And could you maybe give us some couple of more examples where you applied conformance checking and the findings were pretty vital and important?
So one of the obvious areas is really the area of compliance, right? So you have, and to name a very simple example is GDPR, right? We're confronted with this on a daily basis. Even in the current COVID pandemic, the Dutch government, we get these QR codes for going into a restaurant or for international travel. And the Dutch QR codes show less information than the international ones, but they're part of the same app. And all of this is because of GDPR. So GDPR describes processes. Right? GDPR describes that you can record and store data if you need it for a purpose. Right? That if you were given this for a specific purpose, and you also need it for a specific purpose. Now, think of an interesting scenario where a call agent that in the health organization that sends out QR codes is calling you because you had a positive PCR test.
Okay.
And that call agent uses your data for the correct purpose. So that's fine. And now that same call agent accesses your data and sends it by WhatsApp to his neighbor or friend. The data access itself is not a problem. So there will not be any system in place that flags the data access here. At the same time, the data is not being used for the purpose that it was collected for. So piggybacking this purpose in the process itself, and then using conformance checking techniques to identify whether certain data access was appropriate for that particular purpose can help you to identify these kind of problems. And they are not trivial questions. Like in healthcare, nurse can look at the patient records only if the nurse is actually treating the patient. But sometimes the nurse is not treating the patient, but the doctor on the other side of the room asks, can you quickly look what the value of this test is? The nurse can do that. But how do you deal with that in terms of a process? If you look at conformance checking, you will be able to identify this. You identify that a specific activity was executed by person X out of the context in which this activity should be executed. What is very challenging in the area of conformance checking is to correctly translate this to the process level. Because it might be a violation on the model, right, where the model also includes the rules and regulations, but it's not a violation in the process. It's perfectly explainable. So there we see, I think there is a big challenge still to overcome, to make also this tooling more useful in practical scenarios, to really make this clear distinction between the deviations, the low-level deviations you might find between a model and a data set, but the actual implications on the level of the process, the environment, the context.
So in a way, the model or the conformance checking is only ever as good as the model that it relies on. And in that sense, how good must the model be is specifically in compliance, where it must capture all the things that what can happen and all the things that can't happen. Because as you said, there's a lot of ways that the users find of subverting the system and going around it. And is it even possible to capture all this behavior?
Sometimes, yes. So there is, for example, the work of Elham Ramazani, who managed to translate a large collection of rules, compliance rules, into fragments of process models, and then use that to to do conformance checking and identify deviations. And building on that, one of our PhD students is also like trying to do something similar in the context of GDPR. So yes, you're absolutely right that the model is vital here to do this correctly. But the notion of a model should also be seen a bit broader than just a process model. So that can be a translation of a set of rules, sometimes a translation of a set of business rules, legislation, anything that is essentially restricting what should be done in a process.
Mm-hmm. Now, there is a broad consensus among process mining experts that conformance checking will become more important. And you also mentioned that it's becoming more and more used in the implementations and also in practice. What will drive this adoption of conformance checking, and how can also we, as let's say, implementation partners for these corporations, help incorporate conformance checking into our activities and get the interest from them as well?
Yeah, so I agree that conformance checking will become more important, and I think it will also be partly due to the fact that the low-hanging fruit that you can get with process mining or process discovery technology, it's sort of already gone, right? If especially if a company does this in a continuous cycle, they've grown used to the charts that are produced by commercial tools, and like somehow in the background alerting the end user of these process mining solutions to the fact that something is deviating from the picture that they've been looking at all this time, that will be helpful to understand why the picture is going to change next week. Right? So if you purely do discovery and you would look from 1 week to the next, and there is a real fundamental change in the process, then you will look at different pictures. And you have to start wondering, why did my model change? With conformance checking, especially if you do this online, you would be able to signal, look, there is something changing here because there are deviations popping up with respect to the original process. So you have some sort of early warning. What also is, I think, a challenge in the process mining research is the fact that most of the tools and techniques assume that a process is a monolithic thing that exists only in the context of that one process or that one organization. So when you, as a user, look at a model, you think that's your world. But in practice, it never is. Right? There is always 100 other processes that touch each other. They touch each other because the same person is involved, the same employee is working on these two cases, so that employee cannot do two things at once. They touch each other because this is coming from the same customer, two different requests to the same organization. They touch each other because a backlog incurred in a particular process at a particular point in time causes delays 2 weeks later in a totally different point of the organization, because suddenly there is an increased workload and nobody saw that coming. So this multidimensionality, this notion of networks of processes being interconnected, that is also where I think conformance checking techniques will start helping to identify properly where the touch points actually are.
So this is kind of a root cause analysis in a sense, right? Because we can see, for example, that a previous activity caused another activity, right? So that's a direct relationship, right? But if we look a little bit more deeply, like you said, if things happened 2 weeks ago, this can have some sort of effect sometime down the road of increased workload. Now, how does that relate to conformance checking and the future of this?
Yeah, so to give you there are two examples, I think. One is from a project that we're running with a production company. So really a factory, right? They make stuff. And a production line, you can consider this as a process where two products, one after another, is being produced.
Mm-hmm.
And if you look at these products in isolation, you will find that there are minor deviations with respect to the defined process. But if you put all the products together and try to do the conformance checking on a much broader scale, so it's the same production process, but now you're not considering each product individually, you're considering all the products as they actually went through according to the data, then you find that the way to explain the deviations changes when you look at all of them together. For example, because you see in the data that a resource that you expected to do something is working somewhere else. So that resource cannot have been doing this activity that's not logged. So you need to come up with a better explanation for that, right? So it's not necessarily yet root cause analysis, but it is allowing you to identify differences between models and logs at a much larger scale than at individual products. When you think really on root cause analysis, I should mention the work that Dirk Vaarland is doing with Van der Lande Industries, where he really tries to make images of how objects, in his case suitcases, go through a system, a baggage handling system at an airport, and how small deviations in this routing of a suitcase, like by the way he presents this visually, you can actually see where the whole problem started. It's not a process model as such, right? It's a different view, but it definitely is something where a small deviation at some point translates and propagates through a network of interconnected systems. So that is definitely root cause analysis.
This is really fascinating, and I would just say that if you're interested more in the topic of conformance checking, just please go and buy the book about conformance checking and read out more into that. There's a lot of math as well, so I need to warn you, but it's mostly fun.
Well, the first part of the book should be accessible, right?
Yeah. I can confirm that. However, let us switch the gears here a bit, and I also wanted to kind of ask you about ICPM, which both myself and Patrick attended, which was in Eindhoven in 2021. We discussed it briefly also on our show, but since we have you here, could you tell us what ICPM is and what is your relation to that?
Right. Yes, of course. So it was very nice to see you in Eindhoven in November, in the middle of a pandemic, where we had a very successful live conference. So ICPM is the International Conference on Process Mining. It's formally it's an academic conference, right? So it's about research in process mining. Process mining researchers meet and discuss the latest work. They publish their latest achievements there. But at the same time, it's a conference that also aims to bring together the industrial partners on process mining. So one day of this 3-day event is dedicated, and next year will even be a 4-day event. One day is really dedicated to our industrial partners. We discuss, we ask companies to present their use cases, their applications of process mining in real life. And the idea is that this is a venue once a year where we meet. We talk to you guys directly. We come up with new ideas. You can tell us what we should do research on, and we can tell you what you should be implementing. And then we come away with 2 slightly changed viewpoints, but at least it ensures that we keep doing relevant research, and that you guys are also aware what is going on in the academic world. And you, so. Back to ICPM, it's a conference. It's vendor independent. That also means that the vendors use this as an opportunity to meet each other. but there's always a lot of interaction. I specifically, after this year's edition, I got a comment from a company that said, tell the vendors next time to send more engineers, because I talked to the marketing people and that was fun, but I would also like to talk to the engineers of my competitor. This is something that I think characterizes this open community. It's an annual event, so we've been organizing this since 2019. Will was the first to host us in Aachen. In 2020, we were supposed to go to Padova, but unfortunately, COVID turned that around. And Massimiliano De Leoni did a fantastic job in making this a online event, online conference. And in 2021, we met in Eindhoven. The first week of November, our government locked down the country in the second week of November again. So we were very, very lucky to see everybody live. Next year, it's late October in the beautiful city of Bozen-Bolzano. If you got a chance,
I will be there.
Go there. Yes.
We will be there for sure.
Yeah. So, Boudewijn, let me ask you, what is your role in the ICPM? You already mentioned that you're organizing, but what is your role here?
So at the moment, I'm chair of the task force on process mining. So the IEEE task force on process mining. I took over the position as chair from Will because he did that for a few years, but he felt that it was difficult to combine with his position in Salonis.
Mm-hmm.
And we also want to rotate this position frequently. And as chair of this task force, it's my duty to ensure that the ICPM gets organized, but I don't have to do it myself, fortunately. So I'm very happy with Marco Montali organizing it this year, and I'm very much looking for volunteers to host us in the years to come. The task force itself is it's backed by the IEEE. It is a group of enthusiastic process mining researchers as well as people from industry that use or apply process mining in their companies. The task force steering committee does not have vendors, so we're also vendor independent. And the aim is to raise awareness of process mining in academia, to raise awareness of process mining in industry, to bring the two together. And so I really want, or we really want, that our research is close to what is necessary from a business point of view, and that we are also being fed with data from you guys to work with really challenging data sets, because in the end, that's what brings research ahead.
So hopefully we can contribute to that a bit during the podcast and bring these worlds together.
Yes, absolutely. So if any of your listeners feels that they have a data set they are willing to share publicly with a organization or with this community, for example, in the context of the BPI challenge that I mentioned a couple of examples of already, please reach out to me, and I'm sure we can make that work.
Sounds great. Speaking of which, where can people find you, reach out to you, or get to know any of your content and if your published papers and so on?
There's the conformance checking website, right? There's also my homepage that should be updated. But you can find me on the university's website, the IEEE Task Force, processmining.org. You will find links to a lot of things everywhere. So I don't have a decent homepage. I'm very sorry. I'm very bad at making websites. That's just not my cup of tea.
Either way, you will find a direct link to any of those websites that Boudewijn just mentioned in our show description. And for you, dear listeners, this will be an end of today's episode. So Boudewijn, thank you very much for coming. It was a pleasure to listen to topics of conformance. And I'm kind of sorry that we didn't get to that earlier, but I'm still happy that we get to that eventually.
It was my pleasure to be here today.
All right. So thank you very much. Thank you for listening. As usual, if you have any questions, any recommendations on future episodes, future guests, or someone who you just would like to hear from, just reach us out on LinkedIn. We are pretty active there. You can find us on Minding Your Business. We also have a website where you can listen to all of our episodes on mindingyourbusinesspodcast.com. And we are also available at email if you want to write us an email with any questions whatsoever. So mindingyourbusinesspodcast@gmail.com. Leave us a rating. It's always nice to hear back from you. And talk to you, Patrick, in the next episode. Thank you very much. Bye-bye.